welcome back to and today we will discuss another topic from compiler designs, intermediate code generation, backpatching. Today we will see backpatching to generate intermediate code for boolean expressions. I'm your friend Akansha Banerjee and let's together start learning with a smile on our face. Okay, so let us write the grammar first. B derives B1 or M or B1 logical and M or not B1 or true, maybe B1 or true or false or B1 relation operator, and next will be M derives absent. So let's write the semantic actions for each of these grammar rules. First, B derives B1 logical or M B2. Okay. Now in backpatching means that we are generating the intermediate code, but to fill in the goto's address where we have the target address for the goto jump, we do not know yet, as ahead the code, the target address, the instruction for the target address has not been generated yet, so we don't know the instruction number what we have to fill. That's why what we will do, we will leave the places blank of the go to jump instruction, the target address, we will leave it blank, and as soon as we know that target address is address number, we will go back and fill in that blank. So how do we know that what was the address where a blank target address is there? So for that we will maintain two lists, B's conditions true list and false list. We will fill in the instruction where a blank is there and the target address of a true means if B1 is true. Okay, let us see an example to understand this. Okay, so there are always, for any condition there will be two cases. If x greater than 100, see, two cases will be there. Either this will be true or this will be false. Correct? So let us number this as 100. Okay, 100th instruction, this if condition, either it can be true or it can be false. So we will write in the intermediate code, we will write like this: 100 if x greater than 100. That means if this condition is true, then we will jump somewhere. 101 will be go to. That means if this is false, we will jump somewhere else, right? So this is this 100th instruction, we will put this 100 number in the okay, we don't label this one as 100. Let us label it as B1. Okay, so B1 dot true list, this will contain 100 because whenever this condition is true in the 100th instruction. Okay, the true address, target address, has to be filled over here, and B1 dot false list, here we will push in the list with address number 101. That means the target address, whenever this x greater than 100 condition is false, the target address where we have to go, that has to be filled over here. Okay, I could explain it to you. Okay, so here we know that if B1, this is logical OR, if B1 is false, okay, if B1 is false, we have to check the code for B2, right? So we know, and this, what is this M? This M is holding the instruction, the instruction number of B2. Okay, so we know that if B1 is false, we have to jump to target address B2. So as we know the target address, we will use the backpatch function to fill in this B2's address in the go-to of this B1, right? So backpatch B1 dot false list, right? False list. Whenever this is false, we are checking this condition. False list, comma, the address will be m dot instruction. Okay? That means inside the instruction numbers, false lists arrays instruction numbers, we are filling in the target address of P2. Okay. Then what about when this condition B is true? B dot true list will be equal to, where it is true, we will merge both. When B1, B2, both true lists will be part of B's true list. That has to be filled in. The target address we don't know yet. So we'll merge B1 dot true list and B2 dot true list. Okay. And B dot false list. When this whole condition is false, we know that B1's false list, we are already filled the address with B2's, right? So only B1's true list is left out, right? And we have filled the B1's true list as well. That was B's true list, right? So what is left out? B2's false list, right? Yeah. So whenever B2 is false, B2 dot false list, then the whole condition is false, right? Next is B derives B1 logical and N. So do we know the go-to blanks where the target address is? Okay. So whenever B1 is true, we have to jump to B2, right? We have to check both has to be true to be overall. So we can backpatch B1 dot true list with M dot instruction. Okay. And anything else? When this whole condition is true, B dot true list. When this, oh sorry, equals to. When this whole condition is true, when both B1 and B2 has to be true, right? But B's true list we have already filled in the address of B2, right? So what will be? B2's true list is left, so B2 dot true list. And when this condition will be false, whole will be false. When B1 is false and B2 both are false, right? Any one of these two is false, then this whole condition will be false. So we will merge B1 dot false list and B2 dot false list. Okay, so yes, we have wrote all the conditions. Now we can move ahead with the next one. Okay, next will be B derives not of. Here it will be, we know that B dot true list is equals to B1 dot false list. Mm-hmm. B dot What this means is whichever go to jump instructions are there in B and we are taking negation of that. That means the target address will be the overall conditions true. Wherever the overall condition is true, B1 will be what? False, right? Go to will be filled with whatever go tos where false has to be put in. That will become the overall B's true list, right? Yes. Then fourth is B derives B1. Whatever jump instructions will be in B1, the overall conditions true list where true target has to be filled in, target address, it will be B1 dot true list and B dot false list will be equal to B1 dot false list. Okay, then we have B derives E1 relation operator E2. This is this part, okay. When x greater than 200, this part will be uh, reduced to B, even relation operator E2. Okay. So even relation operator E2 here, two if condition go to will be generated. One for true when the condition is true, one for false, right? Two jump statements will be created. So we have to store the address of the instructions first in the true list and false list. So B dot true list, we will make the list, right? First time we are making the list will be equal to make list function, make list of next instruction. Here the address of the true condition is being stored and B dot false list will be equal to make list of next instruction plus next instruction plus okay. And then we have to generate in the file if, right, e1 dot addr relation dot of e2 dot addr, right? Then go to dash. This will be generated. This will be the true condition where true address has to be filled in and generate dash. This will be for the when the condition is false. Right? Then sixth will be B derives true. What will be there? B derives true and B derives false true will be there. So B dot true list will be equal to make list next instruction. Okay, means only true or false is there. Okay, and then only a go to will be given. This is what? This is unconditional jumps. Okay, dash. These are unconditional jumps. And 7, B derives false. B dot false list. We will store the address of the next instruction. Make list. Make list is storing the address of the next instruction that would be generated. Okay, so I think I have written the semantic actions for all the rules. 1, 2, 3, 4, 5, 6, 7. Yes, 7 were there. Written or and, not. Okay. Yes, we have written all. So this topic is a little challenging. So I would recommend you try to write the semantic rules by yourself. Make an